Hey everyone, here's a video on solving quadratic equations by graphing. We're going to look at the guided practice portion of this worksheet, and then you will have the independent practice to work on as your assignment. So remember that a zero of a function is the value of the input x that makes the output f of x equal to 0. When f of x equals 0, the ordered pair x f of x is on the x-axis. Therefore, the x-intercepts of a function can be called the zeros of a function. And a quadratic function can have 0, 1, or 2 zeros or x-intercepts. So let's look at number 1. We have f of x equals negative 2x squared plus 8x minus 5. First of all, does this open up or down? Well, we can see that there's a negative in the front, therefore this opens down. The equation for the axis of symmetry, that will be x equals, and to find this equation, we're going to use that formula negative b over 2a. And again, remember this is ax squared plus bx plus c. So the equation for the axis of symmetry is negative b, so we'll have negative 8 over 2 times a, which is negative 2. So negative 8 divided by negative 4 is 2. So our equation for the axis of symmetry is x equals 2. Because we know the x value, the axis of symmetry is an x value and it goes through the vertex has an x value of 2. And to figure out the y value, we'll just plug the 2 back into the equation that we started with. So we'll have negative 2 times 2 squared, so that's negative 8, plus 8 times 2, which is 16, minus 5, and that will give us 3. So therefore the vertex is at 2, 3. Now just like the equation of the axis of symmetry matches the x value of the vertex, the y value of the vertex is our maximum or minimum value. So we can put that number here, 3. Because the graph opens down, this graph has a maximum. The coordinate for the y-intercept, that always matches the value for c. So we'll have the x value being 0, and the y value is our c, which here is negative 5. For the x-intercepts, we'll get back to that in just a second. The domain, of course, will be all real numbers, and then the range. It opens down, so it's going to be y is less than or equal to our maximum value, which is 3. So let's graph this. First, let's put the vertex at 2, 3. And remember the 1, 3, 5? We can use that again here, multiply it by our a value, which is negative 2. So I have negative 2, negative 6, negative 10. So starting here, we'll go out 1, down 2. Out 1, down 1, 2, 3, 4, 5, 6. And we can't go down 10 from there, it doesn't fit on our graph, so we'll stop there. And then just pause for a second and make sure that your y-intercept actually matches what you wrote down over here. And this is the point 0, negative 5, that matches, so we've graphed it correctly. So notice our our x-intercepts are not very pretty numbers, but that's okay, we can still solve for them. So what we'll do, let's go ahead and use the quadratic formula. So remember that's x equals negative b, so we'll have negative 8 plus or minus the square root of b squared, so 8 squared is 64, minus 4 times a, which is negative 2, times c, so minus 4ac, all over 2 times a, which is negative 2. So you'll end up with negative 8 plus or minus the square root of 24, which simplifies to 2 square roots of 6, all over negative 4. So actually, let's reduce each of these numbers by 2 because they're all divisible by 2. So we'll get, and also notice these negative signs. So we have a negative 8, we have a positive and a negative 2 right here, and we have a negative 4. So let's get rid of the negative sign as well. So we'll have 8. What was positive would become negative and negative positive, so we'll still have a plus or minus. 2, oops, my mistake, let's go back and do that again. We have to divide them by the negative 1 and the 2. So now we'll have 4 plus or minus the square root of 6 all over 2. So those are the x-intercepts, or the zeros. So we'll have 4 plus or minus the square root of 6 over 2, comma, 0. So there are 2 x-intercepts there. And that's it for that one. Okay, so let's look at another example. X squared minus 6x plus 9. So first of all, does this open up or down? Well, here it opens up because a is positive. The equation for the axis of symmetry is x equals negative b over 2a. So negative of negative 6 is positive 6 over 2 times a, which is 1. So 6 divided by 2 is 3. So the equation for the axis of symmetry is x equals 3. That means that the x value for the vertex is also 3. Plug the 3 in to get the y value, so you'll get 9 minus 18 plus 9. That all cancels out to 0. So the vertex is at 3, 0. We know this value 0, so the maximum or minimum value must also be 0. This graph opens up, so it has a minimum value of 0. The coordinate for the y-intercept is always 0, comma, c, which here is 9. The x-intercepts we'll get back to. The domain is all real numbers. This graph opens up, so the range will be y is greater than or equal to our minimum value, which is 0. So let's graph this. Vertex is at 1, 2, 3, 0. The 1, 3, 5 is multiplied by a, which here happens to be 1, so it stays the same. And we're going to go up. So out 1, up 1, out 1, up 1, 2, 3, out 1, up 1, 2, 3, 4, 5. Make sure that your y-intercept on your graph matches your coordinate of y-intercept over here, which is 0, 9, and it does. So we're good, and then we'll just connect our points so we have a graph. Okay, and then there's the graph, and we'll notice that our zeros are x-intercepts. There's only one, which happens to be our vertex, so we'll leave that the same. We'll get 3, 0. Okay, and one more of these. Negative 3x squared minus 6x minus 4. This graph, the a value is negative, so it opens down. Oh, let's write that over here, down. The equation for the axis of symmetry is always x equals, don't forget the x equals. So we'll have negative b, so negative of negative 6 is positive 6 over 2 times a, which is negative 3. 6 divided by negative 6 is negative 1. So the axis of symmetry is x equals negative 1. Therefore, the x value for the vertex is negative 1. And to get the y value, we'll plug it in. So we'll have negative 3 times negative 1 squared. So we'll get negative 3 minus 6 times negative 1, so plus 6, minus 4. That equals negative 1. So the vertex is at negative 1, negative 1. So this negative 1, the y value, is going to be our maximum value because the graph opens down, so this graph has a maximum. The coordinate of the y-intercept is 0, comma, c, which here is negative 4. We'll get back to the x-intercepts. The range is, domain again is all real numbers. And the range, this graph opens down, so the range will be y is less than or equal to our maximum value, which is negative 1. Graphing now, we'll go to negative 1, negative 1. The 1, 3, 5 gets multiplied by a, which is negative 3. So we'll have negative 3, negative 9, negative 15. So out 1, down 1, 2, 3. Out 1, down 9. So it goes off our graph already. So we'll just leave it like that. Messy, sorry. Okay, and then the x-intercepts, it does not cross the x-axis at all. So we'll just say none. Okay, for this next part, you are to find the vertex and zeros of the x-intercepts for the following functions using a graphing calculator and round answers to the nearest hundredth. Unfortunately, my calculator on my computer is not working right now. However, you have already seen this before. But on the top of this screen, you can see that I've written down some reminders. So if you're given this equation, first you will type that equation into a graph into your TI Inspire calculator. To find the vertex, you'll go to Menu, Analyze, Maximum or Minimum, depending on if this graph opens up or down, and then you'll click on the left and the right of that point, the vertex, and then it will give you the ordered pair for that vertex. Very similarly for the zeros, you'll go to the Menu, Analyze, Zeros this time, and you'll click on the left and right of each point, and you'd have to do this for each of the zeros. It's always good to remember that you have to make sure you can see the whole graph before you do the Menu Analyze, because otherwise you're going to have to zoom out. You're going to have to exit out of it, zoom out, fix the screen, and then go back. So really I should have said type the equation into a graph and then make sure you can see the whole graph and then go to number 2. I've written down the vertex and the x-intercepts for you so you can check them out there and verify that your answers are correct. And then for these last 3 problems, I would like for you to set up and try to solve them. I've given you the answers on the right-hand side of this screen, so that way you can check your work when you're finished, and also to check mine as well and let me know if I did something wrong. But remind me to do these in class with you the next class, and I will see you later. Have a great day. Bye.